Okay, so welcome to this lesson where we shall be calculating the resultant vector. We've been given a number of vectors. Okay, so before we even solve this question here, we have to know a lot of concepts that we are going to use to solve this question. Okay, so there is the issue of resolving the vectors. Okay, and there's also the issue of understanding the terminologies that are being used, okay, when describing these vectors, okay? So I'll start first of all by explaining how we can find a resultant vector. And then I shall also explain some different terminologies, the one that we are seeing, some of them we can see them here. If they say 40 degrees east of south, what do they mean? Okay, or they say a 200 Newton at minus 120 degrees, what do they mean? Okay, so we are going to know what those concepts are, and then after we know, we're going to solve this question. Okay, so let's go to my board here where I'll be explaining those concepts. Okay, so we are looking at vectors. Okay, we're looking at vectors, how to find resultant vectors. So these vectors, by definition, we said what? Okay, we said these are the quantities that have a magnitude and a direction. Okay, so meaning if I write maybe 100 newtons, okay, and then I say this 100 newtons is at 30 degrees. Okay, so this here, the 100 newtons is the magnitude. Okay, and then the angle is the direction. Okay, so when you're dealing with vectors and they tell you to find the direction, okay, they just mean find the angle. Okay, direction is angle under vectors. Okay, don't say start saying east, north. No. Okay, when they tell you find the direction, they're just simply asking you to find the angle at which that vector is. Okay, so this here can be an example of a vector, what I've given, 100 newtons at 30 degrees. Okay, so it is important to understand that these vectors, okay, these vectors that we are given, okay, their angle is always read from the positive x-axis, okay? So their angle is always read from the positive axis. What do I mean? Okay, so for example, this 100 Newton and 30 degrees, it means it's like this, okay? So let me draw my x or y plane here, okay? If they say 100 Newtons at 30 degrees, they just mean this vector is somewhere here, okay? And then this guy here is our positive what? X-axis. So remember in vectors, we always read this angle from the positive x-axis. So it means from 0 here, I've gone and I've reached what? 30 degrees, like this. So it means this is my 100 newtons, okay, at what? 30 degrees. Okay, don't add Celsius. We're not dealing with temperature, okay? We're just dealing with direction. We're dealing with angles. Okay, so it's important to know that. Okay, so all the angles in vectors, or we're dealing with vectors, are always read, okay, from the positive x-axis. Okay, so it is important to know that this x or y plane is divided into 4 quadrants. So this is the first quadrant, the second quadrant, we have the third, and we have the fourth. Okay, so this line here represents the 0 degrees. This line here represents the 90 degrees. And then this line here, let me extend it a bit. It is the 180 degrees, okay? Then this line down here is the 270 degrees. And then when we come back here, we find our what? 360 degrees, okay? So any vector that we can get is always read from the positive x-axis, okay? Meaning that if I have, let's say, another vector here like that, okay? To find the angle of this vector here that I've drawn, this one here, okay? Let me show it another color. I have to move from the positive x-axis, which is this guy, all the way to where the vector is, like that. So the angle, okay, to reach this vector here is all this angle that I've drawn in yellow, all the way up to reach there, okay? And then what if I have another vector that is like this? Okay, if I have another vector that is like that, and then they tell you to find the direction of this vector, we're just trying to find the angle at which this vector is. So how do you find that angle? You always start from the what? Positive x-axis. You go like that all the way until you find your what? Your vector. So this whole blue angle here that I've drawn, it will be the direction of this what? Vector. Okay, so if you're given a vector and a direction, then you can easily resolve it into what we call as components. Okay, so we have the x component and we have the what? R component, the y component, I mean. Okay, so how do you find the x? How do you find the R? Okay, so we're going to do this. So if, for example, this here is my x or y plane, okay, and then I had that same vector that I had, okay, the 100 newtons, and then I had a 30 degrees here. Okay, so this vector here can be resolved into what we call as components. Okay, so we have the y component and the what? The x component. So how do you find this y and this x component? Okay, so the y, let me start with the x. The x component is always between the vector. Let me not say that, okay? The x component is always the one where the angle is, okay? So if this is my vector here, it means my my x component will be this guy here, okay? Then my y component will be that guy. So how do we find this x component here? We're just going to multiply this magnitude, okay, multiplied by cos that angle. So this would be 100 cos what? 30. So the one where you have a line, okay, in which we have an angle between this resultant vector and the component is the one that always has the what? The cos. Okay, and then here, this side, you see that we don't have any angle here. It's the one that takes the what? The sine. So this will be 100 sine 30, like that. Okay, so this here is the y component, and then this here is the x component. So whatever we are going to do, okay, we'll have to resolve the vectors given into their y's and x components. Okay, so if you have any questions on what I've explained, you are free to ask. Okay, so this x component is usually represented by Rx, and then this one here is usually represented by Ry. Okay, so if we want to find the direction of this resultant vector, so the R is this guy here. If you want to find the direction of this resultant vector, you have to use this formula. Okay, you say tan the angle that is given, which is 30 there, is just equals to the R component on top here, okay? The y component, I mean, and then down there you have your what? Your x component. So if this angle is not given, you can still find it. You're just going to say angle is equals to the tan inverse, okay, of y component divided by x component, like this. So this formula here will be very important to use, okay? And let's say you have not been given this resultant R. You've just been given this component and this component. How can you get back this R here? You use this formula. Just say R, which is the resultant, is equals to, okay, the x component, and then you square it, and then plus the R component, and then you square it, okay, and then you take the square root of everything here, okay? So this formula here, we are going to use it to find the what? The resultant vector, okay? And then the direction of that resultant vector, we said it would just be tan inverse, okay, of the y component divided by the what? X component. So these two formulas here are very important. Okay, so I've talked about the formulas, and now I'm going to talk about some special terminologies that they use. Then after that, we can solve the question. Okay, so if they say a vector is, let me say, due north, okay? Okay, so they say a vector is due north. What do they mean? Okay, very simple. Okay, so I'll start with the due north. So if they say due north like this, okay, they mean that that vector is just at what? 90 degrees, okay? It's just at what? 90 degrees. So if I have my x or y plane like this, it means my vector starting from the origin is going at 90 degrees. This one here, the one I'm drawing in yellow, this one here, it's at 90 degrees. That would be what? Due north. Okay, so due north means 90 degrees. And then let's say due south. Okay, so due south means that what? Means 270 degrees. That is due south. It means your vector is starting from this point and it's going like that. Okay, and remember I said you always read the angles from the positive x-axis. So if I start from this positive x-axis all the way up to here, you realize that this angle that I'm getting here, okay, someone is writing on my screen. You realize that that angle that I'm getting there is just what? It is 270 degrees. Okay, so whenever you hear due north, 90 degrees. Whenever you hear due south, just know that it's what? 270 degrees. Then let's look at the other dues. So we have due east. Okay. So due east, it means the vector is starting at this point and it's going like this. So you can see it's going to the east, right? Because this is north, south, east, and then we have west this side. So due east means an angle of what? 0 degrees, okay? 0 degrees. Because we said here we have 0. So if you're going due east, it means you have a 0 degrees. Okay? You have not moved from this positive x-axis. Okay, so you're just at what? 0 degrees. And then the last one, when we say due west. Due west means that our angle is what? 180 degrees. So if I start from here and then I go like that, this is what? Due west. Okay, so I'm moving to this. So you notice that if I start from the positive x-axis here and I move like this all the way up to this angle that I'm making there will be what? 180. So it's very important to know these terminologies. Okay, one of them is in our question. We are going to see when we start. So, okay, so know the due north, the due south, due east, and the due west. Okay, and then from there, we can look at these other special 4 terminologies, okay? So the first one is when they say northeast. I'll just write the writing, the abbreviations. What does northeast mean? Okay, northeast, it just means that, okay, it just means that you have a vector that is in between the north and the east. Okay, so if I draw it like this, you have a vector. If this is our north, right? And then this is our east. So northeast, not east north. Okay, northeast, it's an angle. I mean, it's a vector that is between these two like that. So what is the angle if this vector is between? Okay, if the resultant vector is between north and east, what is the angle here? It's just 45 because we say this is 0 degrees, then this is 90 degrees. So we are just halfway to reach this 90 degrees. So it means this will be what? 45 degrees like that. That's what northeast means. Okay. And then when they say northwest, it means, why am I writing east again? Okay, when they say northwest, it means that you have a vector between the north and the what? West. So this is it. So if I have north, then I have west, I have a vector that is between here. Okay, so this vector here is the resultant vector. So what is the angle? Remember, the angle always starts from the what? Positive x-axis. So it will be this angle like that. Okay, so it will mean I have a 90 up to this point here, and then I'm adding a what? A 45 here. So what am I going to get? I'm just going to get the angle to be 135 degrees. Okay, so that is northwest. And then you have the ones for the south now. So we have southeast. Southeast will be this. So this is the south and this is the east. Okay, so you have an angle between south and east like this. Okay, so how are we going to find the direction here, or the angle of the resultant vector, this? Okay, remember we start from the positive x-axis, we move like that all the way up to this resultant vector like this. So this whole angle here is what we're interested in. Okay, so remember this resultant, someone very much okay, so remember that this one here is just between a 90, so it means this one here, just from this point to this point, this point to this point, this is 45 degrees. And then from this point all the way up to this point is what? 270. So we are adding 270, okay, 270. We are adding it to what? We are adding it to 45 degrees. Okay, so this will just be 315 degrees. If you want, you can just say 360 minus this 45 that is here. You still find your 315. And then southwest, okay, it would be like this. So this is the south, and then this is the west. So southwest, it's between the west and the south. So how are we going to find the angle of this resultant vector? We're going to start from positive x-axis all the way up to here. Okay, so this is the angle here. So remember that from here all the way up to here, this is 180. 180 plus this 45 here, going to give you what? It's going to give you 225. So that is the angle. Okay, so if you want, you can derive these angles the way I was doing it, or if you want, you can master them. Okay, just know that northeast 45, northwest 135, southeast is 315, and then southwest is what? 225 degrees. Okay, so these are some of the terminologies that you have to know. And then the last one, which is a very special one, okay? That's also a very special one. When they say something like this, okay, when they say 30 degrees west of south, okay, how are we supposed to obtain the angle here if they say something like that? Okay, it's very easy, okay? So I'm going to give you a mnemonic. So the person that you are going to date, the last person that you are going to date will be the one that you will marry, okay? So how does that help us? It helps us identify that the last direction that we are given here is our reference point, okay? So when they say 30 degrees west of, this should be of, 30 degrees west of south, okay? The south becomes our reference point, okay? So how, or what does this mean? It just means you go to the south and then you move 30 degrees to the west. That's what 30 degrees west of south means, okay? So if I have my XY plane like this, okay? I'll go first of all to the south, okay? So if I'm starting from here, this is my study, I'll go to the south, okay? And then I'll move 30 degrees where? To the west. So I know my west is here. So I'll move like that, 30 degrees. So I'll be 30 degrees here. Okay? So you've seen here. So how do I find my resultant vector here? Remember, our resultant vector should come from here all the way up to here. Okay? So this angle here, from this resultant vector here, from the beginning here, will just be what? 270 minus 30, which will just be what? 240 degrees. Okay? So I'm teaching you these terminologies for a reason, because I don't want you to get confused when you start resolving the vectors, okay, when you start solving the questions. Don't want you to get confused. Okay, let's do one more and then we solve the question. So if I say 22 degrees east of north, what do I mean? Okay, so remember we said the last angle is always our reference point. So we are going to go to the north and then move 22 degrees to the east. Okay, so I'll move, this is my starting point. I'll move to the north, okay, and then I'll move 22 degrees to the east. So it means this is my resultant here, and I have my 22 degrees there. Okay, how do I find my angle here of this resultant? Remember, the angle should always come from the what? Positive x-axis. So we are moving here until we meet this angle. So how are we going to find this angle? We're just going to say 90 minus 22. So we're going to get 68 degrees as our angle. Okay, so I've taught you all the terminologies that you can use, okay, in the questions that you can find on the vector question. Okay, so now we have done the terminologies. Let's try to solve the question. Okay, so if you don't understand anything, please feel free to ask. Okay, feel free to ask. Okay, so let's look at the question. The question is this one now. They're saying calculate the resultant vector if the following vectors act on one point. Okay, so we have been given 4 vectors here. One of them is 100 newtons at 20 degrees below the negative x-axis. Okay, I think I didn't teach this terminology, but I'll explain it in the question. And then we have 150 north at 40 degrees east of south. So we know how to manipulate that, right? And then we have 70 newtons due west. And then we have 200 newtons at minus 120. Even this one, I didn't teach it, but I'll explain it. Okay, so for us to find the resultant here, we first of all have to plot these guys on the x or y plane, okay? And then once we plot them, we resolve each one of these into their x and y components, okay? And then after that, we can draw up a table and find our resultant vector and our direction. Okay, so we are going to resolve them one by one. So the first one is this one. The first one, they said 100 newtons, okay, at 20 degrees below x-axis. Okay, so this means that, okay, so if I draw my xy plane like this, okay, so 20 degrees below the x-axis means that I'm starting from the positive x-axis, which is this guy here. Okay, I'm going like that. And then below means that I have to surpass this x-axis, okay, by 20 degrees. So it will be surpassing like that, and then it will meet the vector there. So this is the vector here that we have. So 100 newtons, okay, at 20 degrees below the x-axis. So this is the 20 degrees here. So it means what is our angle? Okay, what is our angle if we read it from the positive x-axis? It will be this whole thing here, which is 180 plus the 20. You've seen it, okay? So it means the angle here will just be what? 200 degrees. So if you want to resolve this guy into its components, what are we going to do? Okay, we're just going to use this 200 and this what? 100 newtons. Okay, that's what we are going to do. Okay, so what do I want to do now? Okay, so we can resolve this into its components. This is our first angle. So our y component, our x component will go like that. And then, this is the y, right? So this is the y. And then, okay, I wasn't supposed to go up there. Supposed to go down. Supposed to go down. Okay, so this here will be our y component, and then this here will be our what? X this one is our y component. Then this one here is our x component. Okay, so how are we going to find this x component and the y component? We always use the angle, okay, from the positive x-axis. Don't use this 20. Use the angle that you get from the positive x-axis all the way up to here. That's the angle that we are going to use, okay? So it means the y component will just be 100 newtons, okay, multiplied by sine 200. This will be our y component. Then our x component, I'll write it here, x comp will just be 100 cos 200 like this. Okay, so we've resolved the first one into its components. And then the second one was what? Let's check. The second one was 150 newtons at 40 degrees east of south. Okay, so we'll have to draw that. So east of south, so 40 degrees east of what? South. So what did I say about such? So let's draw the x or y plane here and then resolve this vector into its component. So east of south, it means the south is the reference point. So we are going to go like that, south, and then 40 degrees east. So where's the east? The east is this side. So it means I'm moving like that, but by 40 degrees. So I can write it there. This is the vector there, okay? The 40, the 150. 150 Newton. Okay, so here I'm going to have the what? The 40 degrees. Okay, so this is 40 degrees east of south. Okay, so how do I get the angle? The angle, I always get it from the positive x-axis. So I'm moving from here all the way up to what? There. So we know that if I end here, it will just be what? 270. Then plus this 40, what am I going to get? I'm going to get 310. So it means in resolving our components, we are going to be using this what? 310 here. Okay, so let's resolve it into its component. So we have the x component, which goes like that, and then the y component, which goes like that. Okay, so the y component will just be 150 sine, okay, 310. And then the x component here will be 150 cos 310. Okay, so we've resolved the second one there. If there are any questions, you are free to ask. Otherwise, I'll move to the third one. So the third one now says 70 newtons due west. Okay, we know that due west is just 180 degrees. So it's like this. So we are having 70 newtons due west. So this is the west. So we have a vector that is here. Okay, so what is the angle starting from here? We know that the angle here is just what? 180. Okay, and when we resolve this into components, so the x component will just be equals to, what was the length? 70. Okay, so 70, let me write 70 Newton. So 70 cos 180. And then the y component will just be 70 sine 180. Okay, so we have the components for this force. And then let's look at the last one. So the last one here is 200 newtons at minus 120. Okay, so minus 120 means this, guys. So 200 newtons. So this is your 200 newtons at minus 120. Okay, so immediately you see a minus angle here. It means you are no longer moving in the counterclockwise direction. You're just moving in the what? Clockwise direction. So counterclockwise is when we are moving like this. Clockwise is when you're moving like this. Okay, so if I draw my x or y plane here, and then I have 120 degrees there. Okay, it means this is my if this is my starting point, right? I'm moving 120 in this direction. Okay, so I know if I move from this east here to the south here, it has just moved what? 90 degrees. If I moved from east to south, I've moved 90 degrees. But this is what? 120. So it means it surpasses this south. So it means it's somewhere there, like there. So we have this angle here being what? 120. So whenever it's a minus there, okay, you have to move in the okay, we have to move in the clockwise direction like that. So you move in this direction like this. Okay, so for us to find the angle now that we are going to use in order to resolve this into its components, we are going to use this angle from the positive x-axis all the way until we meet this angle. So we know that this angle here will just be, what is the full circle? A full circle is 360, right? Then from this 360, we are moving what? 120. So 360 minus 120, we are going to get 240 here. Okay, going to get 240 here degrees. So we are going to use this 240 degrees to resolve this guy into its components. So its components are going to be the x component, and then we have the y component like that. So the x component will be, what is the length of this? They said 200 newtons. So it will be 200 multiplied by cos 240. And then y component will just be what? Y component will just be 200 sine 240. Okay, so we have resolved all the four vectors that we were given. It means we are ready to find the what? The resultant. Okay, so we're going to be using this to find the resultant. Where we're going to be using this for this one. Then for this one, we are going to be using this and this one. Okay, and then for the other one, where is it now? The last one we're going to be using. Okay, I think maybe I did see the other one. Okay, so this is the other one here. Okay, so once we've resolved all these into their components, we can draw up a table now. Okay, so that table consists of one, the vector with the angle, okay, the x component, and then the y component. Okay, so let's do that. So let's draw up a table here down. Okay, so this table will be like this. So this will be the table. Okay, so this is the table that we have. Okay, so the first one there, okay, the first column I said I'm going to put the vector and the angle. Then there I'm going to put the y component, and then in the other one the x component. So here we have the x component, here we have the y component, and then here we have the what? The vector. Okay, so our first vector was 100 newtons, okay, with an angle of what? 200. Okay, so this here, we resolved it into its component. We found that the first component was just 100 cos 200, okay, and then this was 100 sine 200. Okay, so you can punch this into your calculators to find the actual value there. So if I punch this, I'm getting this. Okay, so here I'm getting equals to minus 93.97. Here I'm getting minus 34.20. I'm just rounding off these to 2 decimal places. Okay, and then the second force that we had was 150 newtons. Okay, and then the angle that we found was 310 degrees. So this will be 150 cos 310 is equals to, and then here we're going to have 150 sine 310 is equals to. Okay, so let's punch this into the calculator. Okay, so I have my answers there. Here I'm getting a 96.42. Then here I'm getting okay, I'm getting a minus 114.91. Okay, so this is here what I get for my second vector. Okay, our third vector was what? Let's find for our vector. So our third vector was 70 newtons, and then we had an angle of what? 180. So this is 70 cos 180, which will just be minus 70, right? Okay, so this will be minus 70. And since this was due, this was going to be 0, but we can show it. So 70 sine 180. So sine 180 is 0. So we are going to get 0 here. Okay, and then we can find the last component. For the last one, we had 200 newtons. And then the angle was 240. Okay, so we said this was 200 newtons cos 240. And then on the other side, to be 200 sine 240. Okay, so what do you get when you plug this on your calculators? Here I'm going to get minus 100. Then there I'm going to get minus 153.21. Okay, so we are done with resolving all these vectors. So what is remaining is adding them, okay? So in this X component column, we are going to add all these. And then even in the Y component, we are going to add, continue. Okay, so as I was saying, we are adding all the components in this X and also all the components in the Y, okay? So we are going to say sum here. Okay, so here, when we add them, we are going to find the X component, their summation. And then on the other side, we are going to find the Y component, their summation. So let's add. So minus 100. Okay, let me be punching. Minus 100, minus 100, minus 70. And then plus 96.42 plus minus 93.97. Okay, so what do I get there? Okay, I am getting minus. Okay, so my resultant Y, I'm getting minus, according to my calculator, minus 167.55. So this is my resultant of X. Then my resultant of Y, let's add. So this, okay, this number here, punch it on your calculator, plus 0 plus minus 114.91 plus minus 34.20. Okay, what are you going to get? Okay. Okay, so my calculator is saying I'm getting minus 3, what is happening to my pencil? Minus 3, 2.32. This is what I'm getting, okay? So we have now everything that we need in order to find the resultant and in order to find the what? The direction. And we said the direction is just the what? The angle that is being read from the positive x-axis, okay? So the resultant error is just found by this formula now, okay? Resultant of x squared plus resultant of y squared. So we have this and we have this. So we can just plug them into that formula and then find our resultant. Okay, so we are going to say this is equals to, and then we just plug in. Okay, so minus 167.55, we say squared plus, we have minus 322.32, and then squared. And then we're taking the square root of all this thing here. Okay, so just punch this into your calculator, should be able to give you the answer. Okay, so I'm going to say square root of, and then open brackets, minus 167.55 squared plus another open brackets, minus 322.32 squared. Okay, then answer. Okay, so my answer is giving me 363. To 2 decimal places, 27 newtons. So this one here is our resultant what? Vector, or our resultant force. So this is our resultant vector. Okay, so the question is not complete because we have to find the what? The direction at which this resultant vector is. Okay, so now let's use, let's draw what we have. Okay, so let me rewrite here my x component. Okay, my x component was minus 167.55. And then my y component was minus 322.32. Okay, so we said that our angle is always tan minus of Ry over Rx, right? Okay, but if you don't draw these resultant vectors, you're going to find a wrong angle, okay? Because the angle is dependent, okay, on where the resultant force or the resultant vector is. So you can only know where the resultant vector is or in which quadrant the resultant vector is by drawing what you have, okay? So this is in the x-axis, and then this is in the what? Y-axis. So we are going to do this. We're going to do this. So this is my x or y plane like this, okay? And then the starting point is always the 0 point. So this is the 0 point. So from this 0 point, I'm moving 167 plus 55 units to the left. Why? Because I have a negative in front here. Okay, so I'm moving to the left like this. This is my y component, my x component, okay? And then when writing this number, I'm just going to write 167.55. Notice that I've not included a minus here because the minus is being shown by this arrow that I've drawn that goes to the what? To the left. And then we also have the what? The y, which has a minus in front here. So if it has a minus, it means it can go up because up there we have positive values. So it will go down like this. So this is my y component. And the value that it has is 322.32. Notice that I've not written the negative. Why? Because the negative is being shown by this arrow. Okay, so it means that what? It means that this resultant here, this resultant that we found here, this resultant vector, is between these two guys here. Okay, so I'm just going to write like this. So this is the resultant. Okay, so we want to find the direction or the angle. So meaning we start from the positive x-axis. So from here all the way up to here is the angle we are looking for. Okay, and we know that from there, this point, all the way up to here, we know that this is 180. So we are just looking for this angle here, so that we add this angle here plus 180 to get our direction. Then we have that. Okay, so now let's use this formula here. Okay, so it will be tan is equals to, theta is equals to tan inverse of the y component, which was 322.32, divided by the x component, which is 167.55. Okay. So what do you get when you punch on your calculator this? So it will be tan inverse of, let's punch this. So 322.32 divided by 167.55. Okay, so I'm getting 1.9237 2 and then 4 2. Okay, so you can punch now the inverse of that. So shift tan inverse of 1.923742. Okay, so I'm finding my angle to be 62.5334, whatever. This one to one decimal place, so it will be 0.5 degrees. Okay, so this here is not the angle that we are looking for. It's not the angle, but we are going to use it to find the angle. Okay, so remember I said we are looking for that small angle. So that small angle is this 62.5. So this small angle here is our 62.5. So to find the direction of this resultant here, we want this O angle starting from the positive x-axis all the way up to here. So we're just going to add 180 plus the 62. That will be our direction. Okay. So we're going to say direction. We can represent it by this symbol. It's just going to be 62.5 plus the 108. So if you punch this on your calculator, you're going to surely get 242.5 degrees. Okay, so this is the direction. And then what was our resultant? Okay, so once you are done finding the direction, you can see the resultant, okay, of the vectors that we were given. The resultant of the vectors is, okay, 363.27 Newton, okay, at an angle of 242.5 degrees with respect to, okay, with respect to the positive x-axis. Okay, the positive x-axis. Okay, so this is our final answer here. So this is the resultant and this is the direction there. Okay, so we've answered the question. I don't know if there are any questions from you guys. Any questions from you guys? Okay, so if there are no questions, then I'll end here. I just wanted you guys to know how to find the resultant. Okay, if you didn't understand, no problem. I'm going to share the video with you so that you can watch it and then you can understand wherever you did not. And if you have any question, feel free to ask me in my inbox. Okay. All right, guys. So have a blessed evening.